All right, so the last little bit of the lab is what's going to happen when you lose your magnet, which is over here. And so, and this change in voltage is really, really small, but basically what I have is I've got a voltmeter hooked up to a solenoid, okay, that has that wire wrapped around it. So this is the north end of the magnet, and so when I put that in that tube, okay, you can't see it, but there's a really, really small deflection on that voltmeter. So if the magnet is just stationary in there, then that voltmeter doesn't change because of the fact we're not saying that there isn't a magnetic field. We're just saying that there isn't any rate of change in the magnetic field. Now, when I put that in, okay, then if you consider this being like the North Pole, okay, and this thing, if this is that North Pole, then that magnetic field is going to be emanating from here. So if I put that in, then it's sensing like an increase in that, and you're going to get a voltage. If I pull it out, then it's sensing a decrease in those X's. So I'm going to give you this reading. I think I measured it. It was like 0.8 volts, something like that. So you're going to have the voltage, which is going to be that fancy little E, that electromotive force. So we're going to measure the voltage across here, okay, that was induced in the magnet, in the solenoid itself. And then we're going to know the fact that when we pull this in, or pull that out, we're changing that magnetic field, and that's what's going to create that voltage and that current. So anyway, that'll be the visual on the last part of the lab. So